Alright, so we're going to get started with Chapter 1, Section 5a. In this video, we're going to just introduce the concept of complex numbers, what they are, how to work with them a little bit. And this is going to help us in later sections where we might get non-real answers. Right, so I'll explain all this in the next slide. Now, up until now, we've only really dealt with real numbers, right? So if we see something like, let's say, the square root of negative 16, right? Up until now, you've been taught to answer this as no solution, right? No solution, right? But really, this is actually a no real solution, and you might have seen this before also, right? Answering a question as no real solution, right? This word here actually has meaning, right? It's not like we're just throwing it in there for no reason, right? Real solution means it's not a solution in the real number system, right? But a natural development to real numbers is a concept that we call imaginary numbers, right? So you see an I over here, and we have I equals the square root of negative 1, right? This is something that we call the imaginary unit, all right? And it sounds made up, it sounds fake, it sounds like it just doesn't make sense maybe at first, right? But hopefully you guys saw in class that it wasn't super difficult to actually work with them, right? It might just be kind of hard to wrap your head around the idea of there being an imaginary number, right? So the name is a little bit misleading because it's not really imaginary, right? It exists, just not in the real number line, right? So I was showing you guys in class. The real number line is something that you've seen for maybe as long as you've been doing math, right? You maybe have seen number lines since elementary school, right? So you see something like 0, 1, 2, 3, all right? But as you progress in math, right, you learn a little bit more complicated numbers, right? So after the whole numbers, you learn about fractions, right? So maybe 1/2, right? What else? 10 over 3, something like that. And then after the rational numbers, you just learn about any sort of real number, right? Integers, right? So -1, right? -5 over 2, right? Negative, positive and negative rational numbers, or fractions, right? Or maybe even radical numbers, right? So you might have square root of 2, right? Over here you might see pi, right? All the way down here, maybe you see pi squared, right? Minus the square root of 2, right? All of these are just examples of real numbers. Up until now, any number that you could possibly think of is a real number. But if you were to have something like the square root of 16, okay, well, it exists because we're able to, conceptualize something like this, but there's nowhere on this real number line that we can fit it, right? It's not going to go anywhere on here. Right, so the next step after real numbers is imaginary numbers or complex numbers, right? Complex meaning just a mix of real and imaginary, right? Complex being a combination of the two, right? So that's just kind of the idea behind this, right? So we're done with no real solution, right? Now, after this lesson, you're going to learn that there are non-real solutions, which are complex solutions, or imaginary solutions, right? And you might also be able to recognize also, like, this square root of -16 is not the same as a square root of -25 or something like that, right? They're both no real solution, but they're not the same kind of no real solution, right? So I know it was going on for a little bit, and I explained this all in class, but if you missed it, this is kind of the idea behind imaginary numbers or imaginary or complex numbers, right? So we define the imaginary unit I to be the square root of -1, right? So this is where our square root of a negative comes into play. We used to say this was no solution. Now it has this form, right? It's the square root of -1. And of course, the natural next step up from that is if we square both sides of these, right? You can just think of it like the square root and the square cancel out, and I squared is -1. All right? And we're going to deal with adding, subtracting, and multiplying and dividing in this video, right? So when you want to add, subtract, or multiply, you want to treat I like a variable. Just like in our radical section weeks before, anytime you're adding, subtracting, or multiplying radical expressions, again, you treat it like a variable, right? And then you'd maybe want to multiply under the radical if possible, right? But with adding and subtracting, right, you can't mix a whole number and a radical. In this case, you can't mix a whole number and an I, right? A real number and an imaginary. Another thing, when your answer includes I squared, right? So you guys can cross this out. This should be I squared. All right, so when your answer includes an I squared, so maybe from a multiplication problem, you want to replace that I squared with a -1 because that's what it is by definition. All right, and in standard form, a complex number in standard form is a plus bi, where a is your real number and bi is your imaginary. All right, so just be mindful of this. If a question is asking for a complex number in standard form, you need to write it as the real number plus the imaginary. And then here's just an example. We'll get into more about simplifying these kinds of radical expressions in the next video, right? But just doing this one with you guys, just to show you how to write it in standard form, right? So square root of -25, we would say that this is no real solution, but we're learning about how we can write it in an imaginary solution, right? So we know that the square root of 25 is 5, right? But because there's a negative under that radical, we need to have a 5i, denoting that it's an imaginary solution, right? So then, and then we can drop the 2 plus, right? So 2 plus 5i is going to be this number in standard form, right? And another thing I have to stress, you cannot forget this I, right? That's a common mistake, right? But if there's a negative under the radical, it is not a real solution. So if you're ignoring or forgetting this I, you have a completely different answer, right? You're saying that an imaginary number is a real number, right? Which isn't the case here, right? You need to be careful with these solutions, right? If there's a negative under a radical, again, we'll do that in the next video, then you need to write an I, all right? But we're gonna start pretty easy today, right? I know I was going on a lot in this slide just talking about it, but in case you're not comfortable with the idea of imaginary numbers, right, hopefully this at least helped kind of conceptualize it a little bit. All right, so our first task with these complex numbers is to just simplify and write in standard form. All right, so let's look at this first example. We'll start pretty easy. All right, 4 plus 7i plus 1 minus 6i. If these were, let's say, variables, right? So let's say it was 7x and then minus 6x, right? How would you combine this, right? You would just combine like terms, right? You're adding the two, so all you have to do, drop the parentheses and combine like terms. We do the exact same thing with our imaginary numbers, right? So we add the real number plus the real number. So in this case, 4 plus 1 is 5. And then we add the imaginary with the imaginary. 7i minus 6i is just going to get you a minus I. All right, and that's all you have to do for this one. Just treat the I like a variable. All right, so something like number 2, right? We have a 1 plus 2i plus 3 minus 2i, right? So we're going to do a 1 plus 3. Real plus the real is going to be 4. 2i minus 2i, imaginary plus the imaginary, is going to be 0. All right, so our answer here is just 4. Now, it's fine that an I didn't show up in your answer, right? But what's important to know is that any number can be expressed as a complex number, right? Because if you wanted to include the I term, what would you have to add to this, right? If you need an I term, it would have to be 0i, right? Because 0i is just 0, right? And it goes away. So this would be the full, complete answer in standard form. WebAssign and I will take it just like this, right? It's okay if it's just a 4 if you just get that part of it. All right. And now number 3 is the same thing, right? This time we have a subtraction sign, right? So what the subtraction does is just changes the sign of everything on the inside of the parentheses, right? We've done this before, right? So it's just going to be 3i plus 2 minus 3i, all right? And then minus 2 minus 5i, all right? And then what cancels here? What are the real numbers? All right, our real numbers are 2 and negative 2, and when we combine them, they go away. Our real numbers here, our imaginary numbers here are 3i and minus 3i, right? And then 3i minus 3i goes away, and the only thing that we're left with is a minus 5i, right? So our answer for this one is just negative 5i, right? Again, and this is fine, right? If you wanted to add a real part of it, it would just be 0, right? 0 would be your whole number. So 0 plus this would be your complex number. But here we just have a pure imaginary number. You might hear me say that a pure imaginary number is a number that doesn't have a real part of it, or is a complex number where the real part of the number is 0, right? In this case, we just have a pure imaginary number, right? Negative 5i. All right, so let's keep this going. Number 4, same thing, right? We just want to the addition is going to keep the sign of everything. The minus is going to change the sign of everything. So we want to change the sign of the 7 and the I, and then just combine everything. So we get 3 plus 2i plus 4 minus I minus 7 minus I. And now let's combine all the real numbers, right? Our real numbers are 3, 4, and negative 7. 3 plus 4 is 7. All right, and then minus 7 goes away. All right, 2i minus I is our imaginary portion, and so that gives us a positive I. And then we bring down this minus I, then we get I minus I also goes away. Our answer here is just 0, right? We don't have any real component or imaginary component, right? We just have 0. All right, this is completely fine. If your answer is 0, that's fine, right? And again, in full complex form, you might see 0 plus 0i. To me, that's a little redundant, right? You just need a 0, right? Because this would be your answer for that problem. All right, and then we can keep this going with an example like 5. Something like this one is a multiplication problem. Again, you want to treat the I like a variable. So if you have a number out front, all you have to do is distribute it, right? So 4 times negative 2 is going to get us a negative 8. And 4 times 3i is going to get us a positive 12i, right? And this is our answer in standard form. Again, it has to be the real number plus the imaginary, right? So we have negative 8 plus 12i. All right. Now, when you're looking at some of the other ones, right, hopefully 1 through 5, you notice they were pretty easy, right? It's just like things that we've seen before, just now we have a different unit, I, right? But you treat it just like a variable, and you treat it just like a radical, right? And now something kind of changes when we go into something like number 6 and onward, right? And you'll see how this works, right? So something like number 6, if you have 2 minus I times 4 plus 3i, right? How would we multiply something like this, right? Let's say it was a variable, right? This is something that you're familiar with. If it was just a variable x, 2 minus x times 4 plus 3x, right? If you're multiplying something like this, your instinct should be to FOIL it, right? So let me erase this, right? To FOIL this, we're going to FOIL it as normal, right? And that's exactly how you do these kinds of problems. So we're going to do 2 times 4 is 8, 2 times 3i is positive 6i, negative I times 4 is going to be negative 4i, and negative I times positive 3i is going to be negative 3i squared. All right, and now from the very first slide, or from the first slide with all that information on it, we should remember I squared, what's I squared equal to? All right, this is equal to negative 1. When you see a negative 1, right, the easiest way to do these is replace that negative 1 by changing the sign in front of the real part of your number, right? So I squared goes away, cross out the I squared, and change the sign in front of the 3. So now we have real number 3, if you're not comfortable with that, I can work it out up here. Originally, we had negative 3i squared, but if I squared, we say that this is negative 1, we end up with negative 3 times negative 1. And negative 3 times negative 1 is just positive 3, right? Real number 3, right? No more I, right? So anytime you see an I squared, simplify it because it becomes a real number. All right, so now let's combine. Our real number with the real number is going to be 8 plus this 3 is going to be 11. And then let's combine the imaginary with the imaginary. So 6i minus 4i is going to get us plus 2i. All right, and this is our answer in standard form. Again, just to recap this one, we crossed out the I squared and we replaced the sign in front of the 3. That's the easiest way to do these. You could multiply it out like this, but it's easy to get messed up with your own work, right? You might see something like this and you'll get confused. All right, just cross it out, make it easier for yourself, cross out the I squared, replace the sign in front. All right, so let's try number 7 now. Number 7 yields an interesting result. All right, so same thing as the last one, let's just FOIL it. All right, so we get 3 times 3 is 9, 3 times negative 2i is negative 6i, 2i times 3 is 6i, positive, and then 2i times negative 2i is negative 4i squared. Remember, we have that 2 times 2, but we also have that I times I, right, to get us an I squared. And in the last one, we said if there's an I squared, just cross it out, replace the sign in front with the opposite, right? So it becomes a plus 4, right, real number 4. And then again, if you're not comfortable with that, just multiply it out. I squared becomes negative 1, and then you get negative 4 times negative 1. All right, so let's combine. Real number with the real number is going to be 9 plus 4, which is 13. And then 6i minus 6i, or negative 6i plus 6i goes away. We just have real number 13, right? And this is an important result. Hopefully we remember seeing something similar to this in our radical section. Right, we multiplied two complex numbers, and we got a pure real number. Right, hopefully you remember what this is called, but if not, we'll go over it in the next slide. All right, so again, this one we multiplied and we got a real number, right? The imaginary is canceled out. All right, so now let's try something like number 8. Right, number 8, some of you might get confused and you might be tempted to distribute the square to each term. And you're going to say that this is equal to 3 squared plus 2i squared. Right, that is not right. Right, do not keep making that mistake. Right, some of you made it in our polynomial section. Yeah, you cannot make that mistake. What we do instead is okay, let me erase this. You want to either memorize the special product, or you can write it out twice and FOIL it. All right, so we get 3 plus 2i times 3 plus 2i. All right, let's do this and let's FOIL it. When we FOIL it, let's see what happens. We get 3 times 3, which is 9, 3 times 2i, which is 6i, 2i times 3, which is another 6i, and then 2i times 2i is going to get us plus 4i squared. All right, and now again, when we see an I squared, cross it out, replace the sign in front with with its opposite. All right, so now we have real numbers 9 and 4, or 9 and negative 4. 9 minus 4 is going to get us a 5. And then we have imaginary numbers 6i and 6i. So when we add those together, we get 12i. So our answer here is 5 plus 12i. All right. So again, this is clearly different from if we were to just distribute the square, right, to 3 and 2i. Right? Do not get tempted to do that. I can't stress that enough. All right, last one on this page, another foiling one, right? Let's just keep going with this one. 2 minus 4i times 3 plus 3i, we want to FOIL as normal. All right, 2 times 3 is 6. 2 times 3i is plus 6i, right? 4i, or minus 4i times 3 is negative 12i. And then negative 4i times 3i is going to get us negative 12i squared. Again, if you see an I squared, cross it out, change the sign in front. All right, and now let's combine. Real with the real is going to be 6 plus 12 is 18. Imaginary plus imaginary is going to be 6i minus 12i is going to be negative 6i. All right, and this is our answer in standard form. All right, so hopefully it's not too bad, right? Should be a little bit familiar. The only new thing is that we're dealing with a new unit I. All right, so in the last slide, we did an example where we multiplied a complex number with another complex number to get a whole number, a real number, right? So these are examples of multiplying a complex number by its complex conjugate. Now, we've done conjugates before in our radical section, right? If we had a radical in the denominator with a whole number, right? So a whole number plus a radical, we would want to multiply by that conjugate, right? And we have here complex conjugates, which are the same numbers but opposite signs. All right, so when you multiply a complex number by its conjugate, the I goes away and we get a real number. And the shortcut to this is to square the real number. Okay, so a squared plus the real part of your imaginary number, right? So b squared, right? I'll show you what that means now, right? So multiply by the complex conjugate. So 10, right? We have 1 plus I. The complex conjugate of this is just going to be the exact same terms, but with an opposite sign in the middle. So if it's 1 plus I, the complex conjugate is going to be 1 minus I. All right, I'll show you the long way to do it, and it's just to FOIL everything out. All right, so we get 1 plus 1, or no, 1 times 1, sorry, which is just 1. And then 1 times negative I is going to be negative I. I times 1 is going to be plus I, and then I times negative I is going to be a negative I squared. All right, and then what do we say about I squareds? These become negative 1s. All right, so we have a negative 1, we have a 1, and then minus I plus I goes away. So we have 1 minus negative 1, which becomes 1 plus 1, which is 2. All right, so our answer here would be 2. Now, if you wanted to do the shortcut, here's how this would work. We would take our real number, so 1, square it. We want to add a plus sign, and then square the real part of our imaginary number. Now, if there's nothing in front of the I, you assume it's a 1. All right, so we get 1 plus 1i, 1 minus 1i. All right, and then the real part of our imaginary number is going to be 1. So we have 1 squared plus 1 squared, which is just going to be 1 plus 1, which is 2. All right, so we get the exact same answer. All right, however you choose to do it is fine. I like the shortcut because it just makes it a lot faster, right, than having to FOIL everything out and then cancel the middle terms, right? It's going to have the same pattern every single time, right? So I feel like there's kind of no use in doing it this way, right? You want to do it in an efficient manner while still doing it accurately. All right, so looking at number 11 now. All right, what would the complex conjugate of 4 minus 3i be? All right, it will be the exact same terms, right? So 4 and 3i, right? But this one would have a plus in the middle. The original one had a minus, so we want a plus. All right, and now let's use our shortcut for this one, right? So the real number is 4, right? So this is going to be 4 squared. Add a plus, and then the real part of our imaginary number is 3. All right, so we have 4 squared plus 3 squared, which is going to be 16 plus 9, which is 25, right? See how quick that was compared to if you were to FOIL it. Now I can do that too, right? We get 16 plus 12i minus 12i, right? And then minus 9i squared, right? Cancel out the middle two terms and then cross out the I squared and replace it with replace the sign in the middle with its opposite, right? So this just becomes 16 plus 9, right, which is 25. Right, so either way you want to do it is fine, but I like this way. It's less writing and is a little bit faster. All right, now multiplying by the complex conjugate is useful in cases where we're dividing by a complex number and you want to get that I out of the denominator, right? So keep in mind, we didn't want in our radical section to have a radical under the denominator. So if I had 1 over square root of 2, you couldn't leave it as 1 over square root of 2. You'd have to multiply by the radical to get the denominator to be a whole number, right? And this was called rationalizing the denominator. So this would become something like square root of 2 over 2. right? Now, when you had something like, let's say 1 over 1 plus the square root of 2, you couldn't just multiply by square root of 2 or minus square root of 2. It'd have to be by the conjugate. So you'd want to multiply by 1 minus the square root of 2 on the top and the bottom. And you don't have to write this down, and this is just an example to kind of refresh your memory, right? And when we did this, we got rid of that radical, right? And when we go to simplify it, now you can verify it yourself, but when you go to simplify it, you get an integer in the denominator, right? So that's the same way with i's, because keep in mind, if I have 1 over 1 plus I is the same thing as the square root of -1, right? Is that not a radical? Right? We don't want radicals in the denominator. If you see an I, it is a radical, right? So we need to get it out of the denominator, and we'll do that in the next slide. All right, so looking at something like number 12, to simplify this, again, there's an I in the denominator, right? So this is not simplified. To get the I out of there, right, we just did some examples like this. We just want to multiply by the complex conjugate. In this case, the complex conjugate is 1 plus I. All right, it's just the exact same numbers, right, but with an opposite sign in the middle. And then the bottom, we did something like this in the previous slide, or the slide before that, right? We got 1 squared plus the real part of I is 1i, right? So it's going to be 1 squared. And 1 squared plus 1 squared is 1 plus 1, which is 2, right? So this becomes a 2. And then we can distribute this 4 to the top, and it becomes 4 plus 4i. So our answer, we get 4 plus 4i over 2. Now we're not done, because we want this in a form where it's a plus bi. We want it in standard form, right? The directions say write it in standard form, right? So to write it in standard form, we can split it up into 2 fractions, right? Hopefully we all agree that if we have a sum or difference in the numerator and a number in the denominator, you can write it as 2 fractions. So it becomes 4 over 2 plus 4i over 2. Right, and then 4 divided by 2 is just 2. 4i divided by 2 is 2i. All right, so here's our answer in our a plus bi form, in standard form. Right, you need to simplify it and get it out of the single fraction, right? Because like this is just a single fraction. That's not an answer in standard form. All right, so let's look at the next one. Number 13, we again want to multiply by the complex conjugate of 1 plus I, right? The denominator here is 1 plus I, and the complex conjugate of that would be 1 minus I, right? So we want to multiply the top and the bottom by 1 minus I. All right, so the bottom, we just did this, right? So I'm just gonna write our answer. It's gonna be 2, right? And if you don't believe me, just verify it, right? It's the same thing as the previous example and in the couple slides ago. All right, and so the top we can FOIL. 1 times 1 is 1. 1 times negative I is negative I. Negative I times 1 is negative I. And negative I times negative I is negative I squared. Keep in mind, the negative I squared, cross out the I squared and replace the sign in front with a plus. So it becomes plus 1, right? If there's nothing in front of the I squared, it's a 1. So then we get, as our answer, the real plus the real on the top is going to be 1 plus 1, which is 2. The imaginary plus the imaginary is going to be negative I minus I. Keep in mind, it's negative 1i minus 1i. It becomes negative 2i. All right, and then when you divide this by 2, all right, this wouldn't be your final answer because you need to split it up. You need it as a real number plus an imaginary. Right, so this is the same as saying 2 over 2 minus 2i over 2. And 2 divided by 2 is 1, minus 2i divided by 2 is I. All right, so this is our number in standard form, our complex number in standard form. All right, hopefully you're getting the hang of these, right? So let's try number 14, right? 4 minus 2i in the denominator, we want to get that out by multiplying, again, by the complex conjugate. So 4 plus 2i. All right, let's do the same thing to the top and the bottom. All right, and then the bottom, let's use the shortcut. We don't want to sit here and FOIL this entire thing out. Use the shortcut. It's going to be the real number squared, right? So 4 squared, plus the real part of our imaginary number squared. So 4 squared plus 2 squared on the bottom. All right, and then 4 squared is 16, plus 2 squared is 4. So we get this denominator becomes 16 plus 4, which is 20. All right. You can write it in another step if it's easier for you to read. I can just see that the answer is 20 from simplifying it already. So I'm writing it out here, right? But that's up to you. All right, so on the top, we want to FOIL this, right? 2 times 4 is going to give you 8. 2 times 2i is going to give you a plus 4i. 3i times 4 is going to get you a plus 12i. All right, and then 3i plus 2i is going to get you plus 6i squared. All right, remember what we do with that I squared. We want to handle that right away, right? Get rid of that I squared, replace the sign in front with its opposite. All right, so then all in all, our answer is going to be real plus the real is going to be 8 minus 6, which is 2. Imaginary plus the imaginary is going to be 4i plus 12i is going to be 16i. And on the bottom, we have a 20, right? Can we leave our answer like this? We cannot. We have to split it up and write it in standard form, a plus bi, right? So this is going to become 2 over 20 plus 16i over 20. All right, and then 2 over 20 becomes 1 over 10. And then 16 over 20 simplifies to 4 over 5. And then this was our imaginary answer, so it has an I. All right, always simplify your answers and write it in standard form, right? If you try a WebAssign problem and it's not taking your answer, double check that it's fully simplified and in standard form. All right, so let's try 2 more examples and then we're done for today, right? So number 15, right? Same exact process. Let's multiply the denominator, or no, let's multiply this entire thing, right, the top and the bottom, by the complex conjugate of the denominator, right? So we get 5 plus I. All right, so let's multiply top and the bottom by 5 plus I. All right, the bottom, again, use the shortcut. 5 times 5 is 25, plus the number in front of our I is a 1. Right, 1 times 1 is 1. All right, so we get 25 plus 5, or no, 25 plus 1, which is 26. And then on the top, we want to just FOIL this out. 3 times 5 is 15. 3 times I is plus 3i. 2i times 5 is 10i. And then 2i times the I is going to be plus 2i squared. All right, now replace the I squared with a negative, right? Replace the sign in front with its opposite. So it becomes, instead of plus 2i squared, it's going to become a minus 2, real number 2. And now let's simplify the top, right? 5 minus 2, right? Real plus the real is going to be 13, right? And then 3i plus 10i, imaginary plus the imaginary, is going to be plus 13i over 26, right? Hopefully you can see that we are not done. We need to simplify this a little bit more. All right, so let's split it up. We get 13 over 26 plus 13i over 26, right? And hopefully you can see that these can simplify, right? It becomes 1/2 plus 1/2 I, all right? And that would be your final answer in standard form, right? Fully simplify, write it in standard form. All right, and now let's try the last one, number 16. All right, so multiplying the top and the bottom by the complex conjugate of the denominator is going to be 4 minus 3i. All right, let's do that to the top and the bottom, 4 minus 3i. All right, simplifying the bottom, right, 4 squared, our real number squared, is going to be 16, plus the real part of our imaginary squared is going to be 16 plus 9, right? And we did this something like this before. It's going to be 25. All right, and then let's FOIL the top. 4 times 4 is 16. 4 times negative 3i is negative 12i. Negative 3i times 4 is going to be negative 12i. All right, and then negative 3i times negative 3i is going to be plus 9i squared. Again, when you see the I squared, cross it out, change the sign in the front. All right, so we get 16 minus 9, real plus the real, is going to be 7. All right, and then negative 12i minus 12i, imaginary plus the imaginary, is going to be negative 24i. All right, over 25. All right, we're almost done. We just want to split it up and then simplify. So in this case, it doesn't simplify, right? 7 over 25, you can't do anything else to that. minus 24 over 25i. You also can't do anything to that, so this is your answer. All right, and then in the next video, we're going to deal with a little more examples of imaginary numbers, right? But hopefully this helps you understand how to work with them a little bit better.